In this session here, we're going to take a look at equations in algebra that have two different variables in them. Once again, you can choose any letters or of the alphabet for your variables. However, the ones that are used most often are x and then y. So those are the two variables I've gone ahead and chosen to use here in this session. And I also chose x and y because graphs, our coordinate graphs system, also use the x and y axis. Okay, let's take a look here. We have an equation that says 6 times x minus 4 times y equals 24. Question is, are there any values for x and then corresponding for values for y that will make this equation true? Well, there are. Let's start and see if we can find one for the value of x equaling 1. What I'm creating here is an ordered pair. And remember, your x value goes first and then your y value is second. What I'm asking is if we make x 0, is there a solution to this problem for a y? Well, let's go ahead and stick in our 0 here and see what we get. 6 times 0 is 6, or excuse me, is 0. 0 minus 4y is simply 4y minus 4y. So if we place a 0 in for an x, that cancels out to a 0. What we're then left with on the left-hand side is minus 4y, and then we still have our positive 24 on the right-hand side. Solving this problem for y, we got to get it by itself. Right now it's being multiplied by minus 4. So to undo that multiplication, we need to divide both sides by minus 4. Well, what is minus 4y divided by minus 4? Well, the minus 4 times y and then turning around and dividing by minus 4 leaves us a positive 1. Because remember, minus 4 divided by minus 4 is a positive, and it'll be a positive 1. So what are we left with on the left-hand side? We're left with y. After we divide by 4 on the right-hand side, what are we left with? Well, we have a positive divided by a negative. So what's our answer going to be when you have a positive divided by a negative? It's going to be a negative. Now we can ignore the signs and just take our absolute values for each of these two and divide them. What's 24 divided by 4? 6. And we have our minus sign out in front from our positive divided by a negative. So when x is 0, y is minus 6. So let's go ahead and put that in our ordered pair and then see if that is, in fact, if our math is correct here. Let's go ahead and see if 0 comma minus 6 is a solution to this problem. We'll put a 0 in here for x. X times 6, 0 times 6 is 0. So there's nothing there then. Let's stick in a minus 6 here for y. Minus 6 times a minus 4 is a positive 24. Positive 24 does equal 24. So this is, in fact, a solution to the problem. Well, let's see if there's another solution. And instead of x is 0 this time, let's see if we can make y 0 and see if that helps us out at all, if we can find the solution. Well, let's go ahead and stick in our 0 for the y. 0 times minus 4 is 0. So 6x minus 0 is just simply x, or 6x. So after we stick in a 0 for x, or for y, we are left with 6x on the left-hand side of the equation. And on the right-hand side, we're still left with 24. Now we still need to get the 6 or the x by itself. It's being multiplied by 6. So we need to divide both sides by 6. 6x divided by 6 is just simply x. And then on the right side, 24 divided by 6 is 4. So our second pair, ordered pair that should work, would be when x is 4, y is 0. Well, let's put that in and see if it works. 4 for x. 4 times 6 is 24. 0 for y. 0 times 4 is 0. 24 minus 0 is 24. 24 on the left does equal to 24 on the right. And so we see that a second solution to this problem exists. When x is 4, y is 0. There's also a third one that works with pretty small numbers, and that one is 2 comma minus 3. In order to prove this, though, let's go ahead and stick these values back into our equation. 2 for x. Positive 2 times positive 6 is positive 12. We'll stick in a minus 3 here. Minus 3 times a minus 4 is a positive 12. Positive 12 plus positive 12 is positive 24. 24 does equal to 24 here, therefore 2 comma minus 3 is also a solution to this problem. So the key here is in finding a value for x, plugging that into the formula, and finding out what the subsequent value of y would be. And then on the other side, you can stick in values that you would like for y, and then you would calculate what the x value would be. Generally speaking, equations with two or more different variables in them have an unlimited or an infinite number of solutions. Answers to problems with two different variables in them are often written as an ordered pair so that they can be graphed more easily. That then is a quick look at equations that contain two variables.